Hey guys, Space Marine 658 here. Today we're going to be talking about how to convert a blueprint into a C++ class. Now, of course, when we're talking about converting, there's a lot of talk about, ways to do it automatically, AI and all that. I think a lot of that is neat, but is not necessarily going to be that useful unless you truly understand what you're doing and what the AI is doing to convert. Most of the solutions I've looked at don't actually fully work with every single type of blueprint, and I'm very skeptical of a lot of them in the long term, because if you don't really truly understand what the AI is doing, it's hard to maintain that type of code. So we're going to kind of try and teach you how to convert your blueprints into C++, and also just sort of best practices when it comes to turning these different things into C++. Now, with that being said, something to be aware of is it can get quite difficult with some of the more advanced topics. So this is going to be a probably 3-part series. We're going to start off here with a very simple class that we're going to convert here, and it's going to have a couple functions we're going to call and some code we're going to run against a widget. So it is going to have some advanced things. But overall, this is going to be relatively simple compared to the later episodes I plan, which are going to contain event delegates and dispatchers and things like that. But yeah, let's go ahead and get started. First, let's take a look at what our class actually does. So we'll go ahead and start up our game here. All right, so if I go ahead and kick us off into the campaign, I've got it set up so that when we get through the dialogue, we're going to see our objective marker appear. So as you can see right now, the objective marker is hidden. We finish here, boom, it appears, and it appears at a specific location, specifically 401 kilometers away. Now with that, we're going to want to actually go ahead and tweak this, right? So let's first look at what our blueprint actually is doing. So on begin play, we're just getting the current widget and we're casting to it, because this will be loaded in the world, so we're not worried about casting here. You do want to avoid casting, of course, if you are doing something temporary or something that you don't want to have constantly loaded. But since the objective marker will pretty much always be in the level, we're perfectly okay with casting to it here. We're setting specifically an actor here, so we're setting ourself, so the objective location actor here, as the target. For the reason for that is I have a world marker class in that widget, and basically I'm just telling it, here's your actor, because it does some logic inside of itself. And then I'm setting that as a variable here so I can access that widget directly. Now there's some things we can do a little differently. A lot of that strictly isn't necessary in the final version, so we might be able to strip a lot of this out just because this is something that I do to give myself access in the future if I actually need these variables. And then we go ahead and just trigger the hide objective, which just goes as the world marker. Are you hidden or visible, depending on hide or show? And then within here, we actually have a function. It basically takes in some variables of a Boolean and a vector. And basically these allow me to show or hide the objective marker as needed. So to see here, basically I go, is the location equal to 0, 0, 0? If true, then we're going to, misspoke a little bit there. If it is not equal to 0, 0, 0, then let's go ahead and set the actor location. If it is equal to 0, 0, 0, then we're not going to worry about setting the actor location. And then from there, I then check C marker. Now, of course, the reason why I do that is because then I can leave the location marker blank if I don't want to actually move the location marker. If I just want to temporarily hide it and then redisplay it, I can do so without needing to fill this out. Because if I'm moving it to somewhere else, I'm never going to be moving it to 0, 0, 0. If I'm ever wanting to get, for some reason, that close to world origin, I could tweak it slightly to be like, 0.1, but the odds of me ever wanting to go to world origin specifically are pretty rare. But yeah, as you can see, there's quite a bit of stuff going on here. And we also have, as you can see here, we have a widget inside of our widget component inside of our actor here that is a screen space widget, as you can see here. So let's go ahead and actually set up the C++ to do this. So the first thing we're going to want to do is go down to, of course, our C++ classes. And we're going to right click and do new C++ class. Now specifically, because this objective location is an actor, we're going to go ahead and select actor. And we're going to call this C underscore objective location. That way we can have a way to differentiate the blueprint and C++ version. All right, there we go. So we'll go ahead and now we're going to go over to our code. And what we're going to do is we're going to close the editor because, of course, we're going to do a lot of writing here, a lot of code. So we don't want to have that up while we're in the middle of working. We'll hit reload all. All right. So a couple things we're going to want to look at. So we have our game framework actor. This basically just gives us access to functions and things that we need for the actor. Something we're going to want to include, which I'm going to copy over here because I have a list of notes over on my side, is going to be the components / widget component. This is so that we can actually reference that stuff inside of our class here. And then what we're going to want to do is set up a few things. Now, of course, when we are going in here, there are a few optional things and some stuff that comes with the classes to begin with. But let's go ahead and create our UPROPERTYs. So we have a couple of these that we're going to want, right? So we're going to have our UPROPERTY for our widget component. So we need a UWidget component. Now this is going to be a pointer to that widget component. All right, and we're gonna give this make sure we have all of that. We're going to give this a visible anywhere. And it's going to make it so that way we can see it within Blueprint. And then it's going to be a Blueprint read only. And we'll give it category equals UI. All right. Now, of course, this is a UPROPERTY, so for some reason the autofill added a void, so we'll go ahead and remove that. Now we've got our UWidget component. Now we're also going to need a root, so we're going to want to add a UPROPERTY for a scene component. UScene component. And this will just be our root. And then we'll give it probably the same. Yeah, we'll probably give it the exact same metadata as the widget component. Now if we go ahead and add the UPROPERTY for our subclass. Now this is going to be our widget class, right? So with this, we're going to want to be able to edit this in case we ever want to change our widget, to be a different widget or anything like that. So we'll just call this a blueprint read write. And of course, same exact category. UI. And this is going to be our T subclass of. Now what this is doing right here. So this T subclass of user widget. Basically, this is saying, hey, the class we're going to put in here is going to be some class that is a user widget. So basically, when our drop down, when we're selecting our widget, the drop down is only going to show us user widgets. Now, of course, if we had, say, I don't know, a custom class of widget, say we built one in Slate, we could put that here instead. Or if, for example, you want to use a different type of widget, let's see, I believe we just do, yeah, you can do a UWidget animation, whatever specific type of widget you wanted to use. But the default user widget covers a lot of use cases. And for the most part, a lot of our widgets are going to be user widgets. All right. And then we also have a property for our, sorry, not uProperty, a UFUNCTIon. This is going to be, it needs to be all capital, UFUNCTIon. This is going to be the one that we're going to want to be able to call anywhere. So this is blueprint callable. Now this is specifically a function, so we want to make sure it's blueprint callable, not pure or anything like that. And this is not going to return anything. You could return, for example, if you wanted to return like a Boolean for successful or something like that. But that is up to you. I'm just going to return void because this is just a function you call against this class. So it's just update objective. And then from there, we're going to pass in a bool, and we're going to do that same BC marker. And then we're going to have a F vector for our new location. All right. So from here, this will give us most of what we need. So we'll go ahead and do quick actions here and create a definition. Now this is going to be our actual update objective. So we need to actually set all of these things. So what we're going to want to do is take our widget. So now we've created a widget class and widget component. If we go to our widget component, we should be able to then go ahead and get widget. And from here, this is where we can actually do something against this widget, right? So we've got this widget. We could go ahead and say visibility. So we could set visibility, right? So we're going to set our visibility. And now this, of course, takes in a eSlate visibility. So if we go ahead and do eSlate visibility, we're going to have to pass in specifically which one we want. So I think for this one, because it's a screen space, it doesn't necessarily matter whether we do collapsed or hidden. For now, I'm just going to do collapsed, but we could do either one. But of course, we don't want to always set that to true, right? We want to do a if statement on our BC marker. So we can say, this is basically our branch, right? This is our, is the C marker, or are we setting this to true or false? Now, of course, the way that we are doing that in inside of blueprints, you know, we're checking this at the end, right? So before we check if we set the visibility, right, we were checking to see if we're going to set the location. So what we can do is do if new location is not equal to, and then we're going to create a F vector because we want to compare, is it equal, not equal to 0. Now, of course, this isn't the exact same function that we used inside, or exact same check that we used inside Blueprint, because here we're saying, is it not equal to 0? But I think technically we used is, all right. Yeah, so I was right. It is dot equals, and then what you can do is you can then pass in a tolerance if you so choose. So for example, right, if we want to say like 0.1 or something like that, to give it a tolerance. And then of course we need to make sure to close the parentheses there. Now, of course we said not equals. So long as that returns true, that will now say, okay, if we're not equal to 0.1 within a 0.1 range, then we'll want to set. Now, I think, you know, a simpler thing here, because if I ever set it to 0, that's the only time I care. So just for simplicity's sake, we're going to simplify this a lot to just, if this equals 0, 0, 0, or sorry, does not equal 0, 0, 0, And then we'll get rid of that and put that here instead. There we go. So yeah, so now it's saying if the new location is not equal to 000, then we're going to want to set actor location to new location. And there we go. So with this, now what it's going to do is if the actor's location is not equal to 0, set the actor's location. Otherwise, it just leaves it where it was at. And then it collapses it if C marker is set to true. But of course, we want to actually do this if it is set to false. So we can either invert it with a exclamation mark, or what's actually easier is just to Control X and then have an else statement down here. And of course, then wrap this in the else statement, and then we'll duplicate it here and then change the collapsed to visible. All right. Now, one of the last things we're going to need to do here is go ahead and make sure that we set up our components here. So what we want to do is actually in the constructor here is we're probably going to need a function or a setup to actually add our widget component to our scene component and root and all that. So we're going to need to create some default sub-objects. So let's go ahead and our root here, we've created that root holder. So let's go ahead and set our root up here. So create default sub-object, and this is a uScene component. And of course, we'll give it the name of root component. This could be any name, but this is just the one you're going to see inside of the blueprint editor. And then we'll set root component, there we go, to the root. And then what we need to also do is then create the widget component. So the widget component equals create default sub-object. And this is going to be, it's going to be a widget, uWidget component. And we'll also give it a name, and you can also use text here. I mean, I don't think heroically that it matters either way. So we'll actually do it both ways, just kind of show off what difference, if any, there is. I think it's mostly by having it be text, it allows you to do some stuff in terms of language conversion, but we're not too worried about that for a widget component. And then do a setup attachment and do it to the root. All right. So now if we have that correct, then we should have that all created. Now the only thing that's left is if the widget component, we want to make sure we set its class. I believe we can do it in the constructor. I'm not 100% sure on that. It's been a little bit since I have done some widget components, but I believe so. We can do an if widget class. Then we can add the component set the widget class. Sorry, I am a little thrown around today. All right, there we go. And then set widget class, and that'll be our widget class there. And then if we had, I mean, I don't think that has any init, because we can then initialize the widget. Yeah, so it should just do the default There's no special function, I don't think, after that we need to call. But we'll init the widget, and then that should be good. Let's go ahead and test that. If not, this might actually have to be in begin play, either instead or as well. But I think this alone should be enough having it in the constructor. So let's go ahead and start and take a look at our code in Blueprints. All right, so it looks like it went ahead and built successfully. So let's actually go ahead and create the derivative blueprint based on that C++ class. So let's do create blueprint class derived or based on this. And this is going to be, we'll call this RC underscore BP underscore, just to kind of differentiate it from the regular BP underscore objective location. And what we'll do is we'll go ahead and put it in the same place as the other one. So it's going to be under our main, game, and quest folder. And inside of here, it's under the objectives. So we'll create it to there. Now, in our original one, we set the a couple of things up and hid the objective, but we're not too worried about hiding it here off the beginning. That's something we can always set up later in there if we so choose to. But we did have these custom functions that we don't have currently for show and hide objective. But to be honest, they're not really needed with this function. These were more for testing. But just to give you a heads up, that's why we didn't create those. But let's go ahead and what we're going to want to do is a couple of things. First, we're going to unhook this, and let's actually go ahead and remove. Let's go to our level there, and go ahead and remove the blueprint version. That way, we can make sure that we are testing against our C++ version. So let's remove this blueprint actor location. And what we're going to want to do in my class here, I'm using my dialog quest system. What I'm going to go ahead and do is basically the exact same thing as I did here, but with our C++ class. Now, you may be asking, get all actors of class, that's a pretty inefficient function, right? And while yes, it is a inefficient function, that's only in the case of the inside the editor. When Unreal Engine builds out to your final project, or I believe even in standalone mode, what it does is it creates, this is very technical and I'm not necessarily sure I know all the technical details, but it basically, from my understanding, it creates like a table. I believe it's called a hash table, where it will store the groups of things together. So as an example, when you're doing GetAllActorsOfClass and you're specifying the class objective marker, what it's doing is it's going specifically to the objective marker hash table and say, okay, are there any class or any instanced objects in here? If so, then give me all of them, in which case we'd have a single one, and we're only going and grabbing the very first instance of that anyways. And so it sounds like an inefficient function, but it is actually quite efficient, because it's not getting all actors of class and checking against every actor, it's just getting it from the hash table. Now, when you're in the editor, I believe it hasn't built the hash table yet, and therefore it is more inefficient inside of the editor. And of course, you wouldn't want to use GetAllActorsOfClass in, like, say, a for loop, because even with it being hashed, that can be very expensive, especially if there's a lot of actors underneath that class that are active in the scene. But it's not something you necessarily need to completely avoid all the time. Something you may want to avoid, though, is the GetAllActorsOfClass with tag, or with interface, or just with tag. While the actors of class will be more streamlined, just like the regular one, when you're doing with tag, then you have to search through all of the elements, all of the array elements that come back. And what it does is it pulls back all the actors of that class and then goes through and looks for which ones have that tag. So that can add a little bit more overhead. With interface and with tag, those actually go over all actors currently active in the level and look for those with the interface and tag. I don't believe, at least in the current version of Unreal Engine, that they hash those. I think because they're more dynamic and they can be added at runtime, the tags in the interface, it can be a lot more expensive to use those when getting actors. But just as a heads up. So we'll go ahead and turn this into our C_BP objective location. And we'll hit compile, make sure we have the variable updated to correct reference. Now we call that exact same function, toggle objective view, and we'll pass in all of this. Now, the interesting thing is, as you can see here, this is a BP objective location reference because it's not actually updated to be the equivalent here. So if we go and get a copy, now we should see it as the C version. So you have to make sure when you're refreshing this class that it is refreshing the output down here. If we do toggle, and as you can see here, now we're not seeing that same class because it's not a class function that we can call like in that same way. But if we go ahead and do toggle objective and uncheck the context filter, you'll see we only have our blueprint version. Now, why is that? If we go back to our code, to our U function, we made it blueprint callable, but we're gonna need to do a couple things here to make it actually used by our system there, and that's to actually call the correct function name. We renamed it from toggle objective view to update objective. Now if we go ahead and call the correct function, as you can see here, it'll pop up and we'll have our target. And we of course want to set the same stuff because we want to see this appear. This should appear almost identically to our blueprint, except that it may be visible before the UI disappears, just because we haven't set up the initial hiding of the objective yet. But otherwise, everything else should look identical. So let's go ahead and test it out and make sure that is the case. All right, as you can see here, it has not appeared, and that's because we haven't actually set up the widget class. And yep, we're going to get here an error because we're accessing none, trying to get an array, because we haven't actually done a couple of things. First, we're going to need to open up our actual blueprint. So let's go to the blueprint here in our Quest system. As you can see here, we don't have our widget component set up. So if we go to our class defaults, what we're going to want to do is grab our widget component and set up our, what we can do is actually, I think in the base class, because we created that widget component class. Let me go to UI, should be under our UI section here. Here we go. So we have our widget class down here. We'll go ahead and set this to our world marker. And then what we need to do is actually in the level, go ahead and drag that in, and we can put this wherever. I like to put it at the world origin. That's just a way to keep track of where all your actors that are just scattered about. And you can also put them in a folder. Sometimes once I get enough of 000 world actors, I'll put them in a folder somewhere. But let's go ahead and try that now. We should now see that appear inside of our screen. All right. As we can see here, we've now got a crash because we got an error exception trying to access our objective location. Now, the reason for that is likely due to missing a redirector. Let's go ahead and send it close. So if we go to our build or our target, we have a UMG set, so that's correct. Let's see. So calling your widget. So likely the issue is because of this widget class setup not being successful here in the constructor. So what we can do is we can go ahead and add it in the begin play as well. The rest of the scene component stuff all worked as we saw. We saw the widget component there. So let's go ahead and try that out. Like I said, it's been a little bit since I have worked with widgets within C++. So we'll go ahead and take a look at this and see. All right. So let's go ahead and open back up our C version. Now, of course, we'll want to take a look at this here. One thing we can do is, so we've got our widget class set. Let's make sure we are set. Let's set to a screen. Now, technically, we shouldn't have to set our widget class here, but just to make sure everything is successful this time, let's go ahead and set it anyways. And then let's go ahead and just start up. Now when we load the campaign, we should see that widget then appear within our UI. All right. And as you can see, it did not crash. Now, something unique is that it is just saying nearby, and that is due to the fact that we didn't pass in that actor reference there. So what we can do is, there's a couple of different ways we could pass that in. Inside of here, I'm passing it directly, just passing a reference to self, saying that, you know, the target is this, but just to make this a little easier on ourselves, because you know there is some casting and things you can do, but we're going to save that for a more advanced tutorial in terms of casting and things like that. So let's actually go ahead, and what we can do is we'll actually just basically copy this functionality right here, because of course this is basically what we want in our C++ version. And so what we can do is at our begin play, we can get our widget component here and get the widget from that widget component. We'll cast it to this. Now we don't necessarily need to store a reference to this here because we're not too worried about that. But with this, that then should then show the correct distance to our widget. So let's go ahead and load this up here. All right, and perfect. As you can see here, we've now got our 401 kilometer away objective marker. But yeah, that's it for today. This was just a very simple dive into converting a class. Of course, there are things that are a little bit easier to do inside of Blueprint, especially when you're accessing Blueprint widgets. So for example, this world marker is a Blueprint widget, so it's a little bit easier to access here in Cast 2. But we're going to dive into a little bit deeper, a little bit more complex topics here in the next C++ video. But otherwise, that's it for today. Make sure to like and subscribe if you haven't already. But otherwise, good luck and good hunting.